Oh, there we go. There's the bell. All right. Okay, all right. So there's the bell. All right. So go ahead, press pause, do the do now, and then we'll go over it. Okay, all right. So let's see. What does it say? Write the inequality. Let's see. Write the inequality. Okay, all right. Solving. Okay, the quotient. Now, what does quotient mean? Yeah, division, right? So the quotient of a number and 7 is at least. How do you write at least 50? At least 50, right? No less than, right? Minimum. There you go. Okay, so we'll solve this. Times 7 on both sides. 50 times 7, 350, right? That's the solution, and we have to graph the solution. Let's see. Well, 350, yeah, so 348. 349, 350, 351, 352, 350, right? Circle to the right, right? To the right. Fill in the circle. Okay, all right, done. Let's see. Unit 8, day 2. All right, so today's the 5th. Homework tonight's on problematic. All right, and okay, all right. So here's what we're gonna do today. So today we'll continue our lesson. Actually, no, not continue our lesson yesterday, because yesterday's lesson was a review, right, on the coordinate system. So hopefully, many of you got a chance to play the stock the shelves game, and then so today we're gonna move into this. Today we're going to talk about distance between 2 points, okay? So this might last only one lesson, or it might go into tomorrow, okay? I don't know yet. All right, so distance between points, all right? Okay, all right. So to start off, instead of, you know how sometimes instead of me doing the lesson in the class, I will show you a very short clip where another person is doing the lesson. So today I'm going to let a different person do it, all right? So what you do right now is this. Go to the blog and watch video number 1, all right? It's 7 minutes long, but it's a really, really good video. The person did a really, really good job explaining it. So go ahead, watch this video right now. Press pause, and then when you are done watching, all right, press play, and then we'll come back. All right, okay, so you're back. So that was a very good lesson. Now, one of the things the way that this teacher did it, I think his name is Mr. Bell. All right. So the way that Mr. Bell did it was that he counted. So he told you how to count the points, right, by using absolute value. All right, which many of you know what that is already. So in other words, right, typically you can just count the number of distances between two straight lines, right, or a straight line, right, between 2 points. So here you have a distance of I'll write over it. Here you have a distance of 3, right? So for example, you have 1, 2, and 3, right? And then, you can count it. So one of the things he did not mention and that I have to mention is that, guys, you cannot count diagonal lines. So meaning, let's say you got a point here and you got a point here. You can't say that's 1, 2, 3. Like it's not 3. Okay, first of all, that line's not straight. It's not 3. It's actually a little over 1 because diagonal lines are a little bit longer than horizontal lines. Okay, you guys get that? So that's why there's no specific number. All right, well, at least not right now at your grade. Like in 8th grade, you'll actually learn how long that line exactly is, but it's not a whole number. Let's just get that out of the way. Secondly, so therefore it's not one whole number. Okay, so don't attempt to do that if anyone were to ask you how to count. Okay. Oh, I'm tough to show you this Khan Academy video also. Wow. Okay, a lot of videos for you guys today. Okay, so right now, hold on, let me see. Let me press pause. Okay, all right. I remember what I wanted to talk to you guys about. Okay, so let's use this as an example. Okay, so let's say, right? Because right now, what you probably think is, oh yeah, every question they'll always give us a graph, and all I have to do is count the points, and everything will be super easy. So let me show you this type of question. What happens if there were no graph, but I give you 2 points? So let's say I give you this point, right? 0, 2, and 3, 2. The question is something like this. If I were to just show you these 2 points, so let's call this example A, okay? If I gave you these 2 points, would you know how far apart the two points are? Right? That's the question. Okay. So let's say, well, I know what some of you might say, Mr. Ng, just graph it, right? Fine. Nothing wrong with that. But what happens if you wanted to save some time, or the teacher says, you know what, no matter what, you cannot draw the graph to do this. You have to solve it without graphing. The question is, well, what do you do, right? So here I want to point this out to you then. Having said that, do you notice, right? Actually, let me give you another example. Okay, so before answering this question, I'll give you another example. Let's say I have another 2 points. Okay, so I'll use purple. Okay, let's say I have another 2 points. Let's say I have a point here, and I have a point here. Okay, so I'll use a purple pen. So let's say this is what we're looking at now, right? Let's say this is problem B, right? So if I gave you these 2 points, can you tell how far they're apart? Okay, actually I should, I want to move this point one place over. Oh wow, really? All right. So, and I say, okay, tell me how far these points are apart without graphing. Right now, I mean, you can count. This is 4. What happens if I do this? Right? I'm asking, hey, what's the distance between 1, -2, and 5, -2? Now, the reason why I set it up like this is I want you to notice, is there any similarities between A and B? I mean, if you look at the graph, you know that there's straight lines, right? I mean, obviously, right? But just by looking at this alone, can you tell what's the similarity between the 2 problems? Okay, this is a little bit hard to say. I know, I mean, it's not easy because you're looking at a bunch of numbers. But think about it for a second. Yeah. The y value on both points are the same. Notice, right? This is a 2, so the reason why I say y value is because, remember in a ordered pair, right? It's xy, right? And this one, same thing, right? xy, xy. So in this one, I don't know if you notice, right? Both the y values are the same. Now, this is not a coincidence. Any lines that are straight on the coordinate plane, now it could also be like this, right? It's going to have either the x or the y having the same coordinate. Okay, so for example, now let me plot this one out for you guys. So let's say we have a problem C. Right, so problem C is right here. So C is the points where it's what? -3, 4. And -3, 1. Notice how this line is straight, right? And therefore the 2 x values are the same. However, the first 2 lines, the lines are horizontal, right? And therefore the y values are the same. So look here. Right, you notice how they're both -2, the y values. So one of the things that you have to notice, all right, is that if it's a horizontal line, the y values are the same. If it's a vertical line, the x values are the same. Okay, you know what? Let me write this down. this might help you. So, okay, all right, write this down. In a graph, horizontal lines share the same what? Y coordinate. And vertical lines share the same X coordinate. All right. So you might want to write this down. Okay. All right. So you might want to write this down. Now, knowing that knowledge, so for example, by the way, so if you look at this guy here, the last one, the vertical line, the x-axis are the same, right? Notice that they're both -3. So that's a rule, I guess. Okay. Now, having said that, let's actually try to solve a problem, right? So okay. So first of all, by the way, all right, maybe typically I would give people extra credit in class, maybe not. All right, for answering this question. The question is this: why can't it be both? So, for example, looking at the first one, why can't you find the distance between 2 points if both the x coordinate is the same and the y coordinate is the same? Why can you not tell me how long the distance is from 0, 2 to 0, 2? Yeah, it's the same point. Like there's no line here, right? What you're gonna end up is you're gonna have 2 points on the same place, right? So that doesn't work. That makes no sense. Okay, that's why you can't do that. Okay, so in other words, what I'm trying to say is, if the y value is the same, then the x value is not the same, right? So again, if the y value is the same, the x value is not the same, and lastly, right, if the x value is the same, the y value cannot be the same. Okay, all right, okay. So here we both got 2 here. So now what's the only difference then? I mean, if both the y-axis is the same, right? What's the only difference? Right, the x-axis, right? So here's the question then. All right, I'll use green. What's the difference between 0 and 3? So in other words, how far is 0 away from 3? Yeah, 3, right? So that's how long the line is. So look, 1, 2, 3, right? How about B? How far apart are they, right? Knowing that these are both -2, so that means there's nothing changes here. So how far is 1 away from 5? Yeah, 4, right? Look, the line, 1, 2, 3, 4, right? And what about the last one? Knowing that both x values are -3, now we got to look at the y value. How far is 4 away from 1? Yeah, it's 3. The 3 distances apart, right? Look, 1, 2, 3. Right? Okay. All right. So, yep, that's the lesson now. How are we doing on time? Okay, let's practice for a little bit. And then tomorrow, so let's practice as much as we can today. Yeah, there's a lot of practice for you. And then tomorrow, to wrap this up, I'll show you the Khan Academy video and the online activity. Okay, so that's even more practice for you. Okay, all right, that said, let's try this one, okay? I know the font is a little light, but I was trying to fit both of these in there. Okay, find the distance between 4, 5, which is right here. I'll make this a little bit more obvious. 4, 5, and 10, 5. Now, on the one hand, you could do what you've been doing, right? And this from Mr. Bell's video, you can count, right? So 1, 2, 3, 4, 5, 6, right? I know the answer is 6. So here's the counter question, I guess. If you were not presented with the graph, what can you do? Okay, again, right? So here we got the points. So let me write that out again. So here we have 4, 5. By the way, you don't need to write this down. I mean, maybe you could write this question down. The difference between 4, 5 and 10, 5. Right now, it's horizontal line. So look, I mean, you don't even need to memorize the rules per se. I just want to make you aware of it. Okay, so 4, 5, and 10, 5. Which two values are the same? Yes, the y values, right? So we're gonna ignore those, right? Because 5 to 5, like nothing changed. By the way, that's why it's a perfectly flat line, right? That's horizontal. So that said, what are the two values that are different? Yeah, the 4 and the 10, right? So my question for you is, how far does it take to go from 4 to 10? Yeah, 6. That's it. So how long's the line? 6, right? Okay. All right. So let's see. Try this next one, right? Okay. So again, I'll write the points out. Again, you can count. I know you can count. Let's see. It's 3, 8. And this one is 3, 3. So the question is, how far is 3, 8 from 3, 3? Well, let's look again. Which other values that are the same? Yeah, these two 3s here, right? The x coordinate. So the question for all of you is, how far does it go from 8 to 3? Or 3 to 8? How far does it take? Yeah, 5 places, right? And that's how you do it. Okay? All right. Let's see. Let's practice. Now, this is the guided practice. So let's do this here, and then I'm going to stop. Tomorrow we'll do the rest. Okay? All right. There's a lot of information here. And I know I have to be careful and go slow. Okay, all right, let's see. All right, let's just get this out of the way. All right, so let's see. Well, let me draw a line so I know to stop here. Okay, all right. Okay, number 1. All right. So see, this is the rule actually. You know what? Take a moment and copy this also. Okay. So I'll give you a couple minutes. Write this down. Okay. Why don't I read slowly while you're copying? Okay. If the points lie in the same quadrant, subtract. Okay, you know what? No, I take that back. You don't need to know all that. It's too many rules here. Okay, all right. Okay, never mind. All right, so find the distance between the pairs of points. So where is this? I'm gonna color code this. All right. Where is it? -3, 1. So we're talking about this one. All right, I'll color code it in green. This point and 2, 1. Okay, all right. I thought it was this one. All right, so these are the points we have to focus on, right? Okay, all right. So different quadrants. So okay, all right, whatever. So, how far is -? Okay, so I know what this one is. This one is more like, you know how these questions, the answer is always positive, and like you go from a positive number, a neutral number to a positive number, positive to a positive, right? Positive to a positive. The question is, what happens when you have negative numbers, such as these, right? Because what you're doing is, so watch. What you're doing is you actually have to cross an axis, right? So in order to, I don't know, ease the burden on your part, think about it, right? So let's use the logic that we used earlier. Have you noticed that these two numbers are the same, right? So we're not going to focus on it. So the question is something like this, okay? How far does it take to go from -3 to 2? That's the question. Now, a graph obviously helps, right? But you don't want to always draw a graph for everything. So, you know, imagine for a second, right? Imagine for a second. Here's how I'm going to help you guys. Imagine for a second, the question is this. How far does it take to go from -3 to 0, right? -3, -2, -1, 0, right? How long is this? Yeah, 3, right? 1, 2, 3. So imagine now you're starting from 0 again. How far does it take from the y-axis, where 0, to this point here? That's right, 2. So how long is this line in total? 5. So that's how long this line is. Okay, so that's what they're saying. How long is it from -3, 1 to y-axis? 1, 2, 3. How long is it from 2, 1 back to this, right? 1, 2. How long is it total? 5, right? 3 plus 2. Okay, that's all. That's all there is to it. Okay, so let's do the rest of these together as a class. Okay, all right, now I gotta erase this. All right, if you didn't get it the first time, don't worry, that we have 3 more examples. Now, where are we? Okay, let's try this again. Okay, negative 3, 3, which one is that? That's this one. Negative 3, 3, negative 3, oh, it's this one. Okay. Oh, this one's gonna be easier. Okay, all right, so it's in the same quadrant, right? Okay, all right, let's not even look at that. Let's keep it simple. How far is one away from the other? Yes, 2, right? That's it. Okay, all right. All right, 2, right? 1, 2. Now, if you want to solve it the way I've been showing you, notice how these two values are the same, right? So what's the only difference? 3 to 1, right? How far is 3 away from 1? Yeah, 2. 2, right here. Okay? All right. Now, I think now it's going to get a little more interesting, so that's good. Okay, what are the 2 points? 2, 1. That's this one. And where's the other point? 2, negative 4. Okay, so that's the question. How far is this one from this one? Okay, imagine, right? So ignore the graph for a second. Let's just put our focus on the 2 points here. So if we have 2 comma 1, now look at both coordinates. What do they have in common? Yeah, they both have 2, right? So ignore the 2 for now, okay? I'm gonna cross it out. Just look at the 1 and the negative 4. How far is 1 from negative 4? Imagine. So don't look at the graph. Just imagine, right? Imagine a number line in your head, right? How far is 1 from negative 4? Okay, so we'll count, all right? So, well, from 0, let me use green. From 1 to 0 here, that's 1, right? And then from 0 to negative 4 is another 4. 1, so 1, 2, 3, 4. So what's the total distance? 1, 2, 3, 4, 5. Okay, you don't need to fill all this out. Okay, don't. Because I sometimes, you know, they'll tell you why I didn't want you to remember this rule. Because sometimes, you know, if you use too many words to explain a simple concept, it just ends up making things more complicated. There's no need for that. Okay, as long as you know how to do it, I'm fine with it. Okay, let's see. Last one. All right, let's use blue. All right, 2, negative 4. Whereas, oh, this one's easy. 2, negative 4, and then 4, negative 4. So, I mean, how far are they apart? Yes, 2, right? Why? Well, these two values are the same. So now you're looking at 2 to 4. How far is 2 away from 4? Yeah, 2 spots. Okay, that's it. So let me recap before we end the day. All right. So the first thing I would like you to remember is this. In a graph, the horizontal lines share the same y coordinate, right? So horizontal line, the first two here, they share the same y coordinate. So this one's 2, this one's 2, this one's negative 2, this one's negative 2. And vertical lines share the same x coordinate. So for in the red example here, both x values are negative 3. So what that means is that to find out how long a line is on the coordinate plane, you have to look at the ones that are not the same, right? So 0 and 3. How far is 0 from 3? 3. How far is 1 from 5? 4. How far is 4 from 1? Yeah, 3 spots over, right? Likewise, when you deal with negative numbers like 2 and 3? No, 1 and 3, right? Like 1 and 3. Look at 1 again, right? Negative 3, 2, 1, right? Notice how these two y values are the same. So the question is, from negative 3 to 2, how far is it? Well, it's 5, right? Because you got to go from -3 to 0 first, right? -3, -2, -1, stuck at 0, and then 1, 2, right? So that's 5 spots over, like we said. And then lastly, 2, 1. I'll change the color now. 2, 1 to 2, -4, right? Notice how the two x values are the same. So what are we going to look at? Yeah, 1 to -4. How far is that? Well, you got the 1, and then 1, 2, 3, 4, 5. So that makes it 5 total. Okay? All right. So I'm going to have to edit the video a little bit. Okay? And that's it. Okay. All right. So go ahead and do the homework, and thanks for watching, and have a good day. Bye-bye. Okay. Oh, there we go. There's the bell. All right. Don't tell me you don't miss that bell.
OMG, that was so good.